Hi, this is Chris. The purpose of this video is to cover the generation of moving loads in ENERCALC 3D. So in preparation, I have a long line of beams here that might represent a crane frame, and I have applied some point loads to the first member in the line of beams. What we're going to need to do is select all the beams that we want the load to move across, and those members do need to be collinear in order for the generation to work properly. Then we can come to loads, generate loads, moving loads. In the moving load dialog, the first thing that I need to do is select the load case that contains the loads that I want to have incrementally moved. And I've assigned these point loads to the live load case, so I'll select live. The next thing we need to do is specify the move step. How far do we want the pattern of loads to move with each generated step? I'll use a magnitude of 1 foot, but I've found by experimenting with this that the program wants to move things in the positive global axis direction that corresponds to the orientation of the members. So we're parallel to the z-axis, and since I want the loads to move from lower left to upper right on our screen, I found that I need to enter a negative value, so I'll enter a moving step of -1. This list just shows the members that we've selected. Notice that there are controls to adjust the members that are included in the generation, so you can add more lines and type in more beam numbers if necessary. But for now, I'll just click OK. So what we see is that pattern of loads has been incrementally moved all the way across the line of selected beams. Now there's a couple interesting things to note here. If I come to tables and then come down to point loads data, notice that I still only have the 3 items in the live load case that represent the composite of the vehicle or trolley that I've moved across the beam. So when I generate moving loads, it does not create additional point loads that will appear in the point load data table. But what it does do is it creates additional load cases. So where I previously had live, roof live, and wind, now we can see that I have a long list of additional load cases, all of which are of the live load type, but they all indicate that they're associated with this moving load, and you can see a reference to the step numbers. And then the really nice thing is that if I come to loads, load combinations, not only do I have the original ACI load combinations that I had defined previously, but now I have a generated set of load combinations that incorporates those moving live loads at each increment along the move. So there are obviously quite a few permutations of combinations and live load positions, and we can see that the program generated all of those for us. So a big time saver in that regard. Hopefully that's been helpful in taking a look at how we can use generate loads, moving loads in ENERCALC 3D.